to our today's live show. And today we are talking about wire sizing for your electrical installation. I am your captain, your host. My name is John Gatehi, and this is Top Heights Electricals and Electricians. Where are you streaming from? Let me know, and I will be so glad to be together with you from whatever location that you are in. Is it Nigeria? Is it Gambia, Malawi, Lesotho? I have followers from across the globe: Netherlands, Canada, Qatar, USA, UK, and I am so grateful. And from the great republic called Kenya. Do you know about it? Kenya is an amazing land for sure, and I'm proud to be a Kenyan streaming live to whatever place that you are in, and I am so glad that you could join me. Now, if you are watching this video in a recorded version, you are very much welcome. Smash the like button if you're ready to get some value. This is in regards to the size of the wire. Size of the wire matters. Why? When we talk about the consumer unit, when we talk about the meter box installation, it matters a lot because you know what? In physics, I was told something that was very, very important when it comes to electricity. I was taught the resistivity of a wire or the resistance of a cable or a conductor. Why does that matter? It matters a lot because number one, if at all the size of the wire is too small for that purpose, it means that the resistance will be increased. But how does that happen? Because when that size is too small, it means that the particles will knock themselves, this effect creating a lot of heat. And another thing was the distance. If at all the distance is increased, the resistance is also increased. So those are some of the pointers to take note whenever you're doing an electrical installation. What more? When it comes to the material of the wire, it also plays a key role when we are talking about the resistance. So if the material is not that which is a good conductor of electricity, it will basically increase the resistance of a wire. Now I'm just laying a foundation when it comes to our today's topic, which is wire size for heating circuits. Once we understand those basics, then it will be very, very possible for us to design circuits, especially when it comes to wiring or basically electrical installations. So welcome to this show, and I am super delighted to be hosting you. All I need you to do is to tell me where you're streaming from so that our cruise ship can be way cruising. I am your captain, and this ship is referred to as Top Heights Electricals and Electricians. And part of my crew is you. You know, you are the crew in this ship, and I'm so delighted to be your captain. Awesome, awesome. Let us continue with our today's session. John, don't be carried away. Come on. Now, when it comes to heating circuits, especially in a domestic installation, what are we talking about? We are talking about the instant shower head. We are talking about an electric cooker. We are talking about that bread toaster. We are talking about that electric kettle. Oh my goodness. We are even talking about a microwave because you know what? There is a heater that is there. And these circuits draw their power or their current from these hearts of any electrical installation, as I usually refer to it, which is the consumer unit. Now, the size of the cable for wiring a lighting circuit is definitely different from the size of the cable for an instant shower head. The same applies when we are choosing the size of the cable for an electric cooker, completely different from that of a socket, especially that is in either the common room or the sitting room or in the bedroom. Why? Because the loads that are applied here or are connected here are completely different. When we talk about an electric uh, uh, cooker, you know, it is a heavy load compared to that charger that can be connected in your bedroom. So definitely the wiring is done in a different manner. And I'm going to talk about it in a short while. Now, when we are talking about, let's say, an electric cooker or an instant shower head, we have, let me begin with an electric cooker. An electric cooker has this fixture here. This is referred to as a fixture. And this fixture is known as the cooker unit. So this cooker unit has these important features here that I want you to understand about today. This switch here activates this socket, you know, and this socket is usually reserved for low powered kitchen appliances such as a blender or sometimes a kettle that, you know, does not draw a lot of current from the source. And then there is this important part here. You see this switching gadget here. This switching gadget or this switching gear or this switch gun here is very heavy. And if you see, take a look at the back, it activates both the neutral and the face. So there is the load there and there is the supply. So at this particular point, we want to understand that this heavy gun here or this bigger gun here is to actually activate a cooker. There is no way that a cooker is supposed to be connected here because this switch here, even the size itself, you know, cannot handle the power that is drawn by the electric cooker. Some of the electric cookers which were supplied before were connected, you know, in this heavy gang here. And they were to be connected like so strictly because they had that hot plate, you know, the hot electric plate whereby you will heat using electricity supply as the source of energy. But you see, most of the cookers that are coming in nowadays are not having that plate, the hot plate, which is connected to the electricity, but they have the various points where all of these points are used for the gas connection. Now, the electric cooker, you find that it has that section whereby it has a connection for electricity supply. And normally, you will find that it has several heating compartments or several heaters, as well as a bulb there, you know, for, you know, to provide or produce lighting so that you can see whatever you're doing, either it's baking, grilling, and what have you. There are so many nice cookers that I'm going even to link on the show notes that you can acquire from Amazon. And I'm telling you, if you get these wonderful cookers, you will be able to connect them in a manner that they will not have issues with you, especially when you're using this cooker unit here. You connect your cooker connector on this part here at the supply, I mean at the output, which at in this part here it is indicated out. So we have the in here. I don't know whether you can see it clearly. The in, I don't know why they put the incoming connection here and then the outgoing connection above. When you have connected the cables here from the consumer unit, the socket here is also fed with power. And then the KUKA connector will be connected at this particular point here. That circuit is only activated by this gang here, you know, when you switch it on or off. Now, look at the connections that are here. You see, that is why this is a circuit that produces heat. Compare that one, even the screws that are connected like so, the screws that are there, compare the point where you are supposed, you know, to connect your wires, and then let me introduce this normal socket. As you can see, where you are supposed to connect your cables or your wires, that connection there, look at how tiny it is compared to our KUKA. So that is for the live connection, that is for the earth connection, and we definitely have this one here for the neutral connection. As you can see it. Check out the screws. Tiny screws there. Compare now with this one, right? So again, let me showcase them like that. There's a big difference, right? There's a big difference because, you know, this one is just a normal socket whereby you can connect your charger, you can connect, you know, a certain plug, you know, that doesn't draw a lot of current. But when it comes to this, then you have those heavy connections there. But why have those connections? It is simply because this is a heating circuit. This is what we are talking about today. A heating circuit draws a lot of current, you know, from the source, the consumer unit. This heating circuit must be wired with a lot of care and a lot of consideration for what the circuit does, especially the appliance that is connected. And when we are doing these electrical installations, we do something that is referred to as beginning with the end in mind, especially for us here at Top Heights Electricals and Electricians. We don't take anything, you know, lightly, especially when it comes to wiring and the fixtures. So the choice of the cables is a priority to us, as well as the fixtures. These are fixtures. And finally, something that is very important to us is how the connections are done. You know, it's not about just connecting it the right way. It is about, have you connected it tightly? Number one. Number two, have you ensured that if you are to backfold, do you know what backfolding is? Let me demonstrate to you. So let's say we were connecting this cable here, you know, the neutral, the return path. I love the neutral so much. Not like I love it. It's my favorite connection in any electrical circuit. So backfolding, let's say you have stripped your cable like that, and we want to create more surface area, you know, for current to be conducted to whatever connection. You backfold, meaning you simply twist it backwards like that. You have created a lot of surface area here. So when you are connecting it to the fixture there, it has a lot of, okay, this one will not get in simply because, you know, but I like it because, you know what, it simply indicates that we have a bigger or a larger surface area for us to, you know, connect our cable there. And so I need to get it in, you know. So that is backfolding. And once it is in, I ensure that I connect it tightly. And when I get it inside, I don't get it all the way up to this point where I have the insulation. I will make sure that when I'm screwing my cable, I ensure that I only screw on the wires there. Again, this one increases the surface area. You know, the point of contact between the wire and that part here that is copper. You see, imagine this connection here has been made so deep, that copper connection. Just look from the start all the way inside. All of that is so that it can increase the surface area, you know. Also, check out the size of, you know, that hole. Let me call it hole for now. That connection for now. It is elongated, is deeper, so that you can have a greater surface area, you know, for the connection of your cable. But if you should not forget is what we are covering today, circuits for heaters, you know, the wire size and also the connection. So let me ensure that we are riding along so well by getting your feedback. Where are you streaming from? You know, this live stream. Where are you streaming from? And if you will be watching our recorded version, smash that like button if at all you are already getting some value out of this. This is an important aspect for you, especially if you are a student that is in electrical engineering profession. To grasp this aspect, you will be at advantage position, because you know what, in my practice of more than a decade, more than 10 years I've been in this game, I have met people that made a lot of mistakes when it came to circuit design. I say that electrical engineers are also designers. They are an architects in this field or in this game. So you find that someone designed a circuit, and instead of using a 4.0 millimeter square wire, they used 2.5 millimeter square for a circuit that required more than that. And therefore, that circuit was having issues, you know, giving the customer a lot of headache. And when I was referred and called upon to go and check it out, I found that, you know what, the only solution to this problem is to change the entire circuit from the source, which is the consumer unit, all the way to where the appliance is connected. Now, let's say we are talking about an instant shower head. You know, an instant shower head is another interesting circuit. Why is it interesting? Because it draws a lot of current from the source. Now, this is my instant shower head here, spoiled from some place, and then this is the switch which normally activates power. Countries don't have, probably use a different appliance, like let's say a heater. So what do you use in your country? Have you ever seen something like this? I'm only demonstrating what I have here, and I'm going to talk about other appliances, other heaters, and other instant shower heads that you know are great and are good. For instance, we have the pressured instant shower heads. These instant shower heads are very good because you know what, they can operate even with low pressured systems whereby the plumbing was not done correctly, or probably the water flow to them is at a very low pressure, but they have an inbuilt system where they can have a pump. This pump will step up the pressure that is coming in to enable these instant shower head operate even with the least amount of water pressure that is flowing in them. And I have several shower heads that I'm going even to link links on the description, whereby you can purchase it probably from Amazon, and you know you will get a very good quality instant shower head. And let me tell you something, you will enjoy such. But if we are talking about this instant shower head, and let me tell you something, you can upgrade from this instant shower head to the pressured instant shower head. And you know, when you do that, it means that that circuit is even heavier than this one. The instant shower head, the pressured one that I'm telling you, it consumes heavy power than this one, because there is a pump that is involved there, and there is also the heating elements that are there. So those are two loads at the same time compared to these that we are used to. Now, this circuit, assuming that you have done an electrical installation, assuming that this person will use this instant shower head that you have fixed for them at that particular point where you are doing the installation, and then they upgrade. For instance, someone watching this video decides that, you know what, I'm going to upgrade, I'm going to buy an instant shower head, and I'm going to buy a good one, a pressured one. Like I've said, I'm linking one in the show notes, that you can purchase from the Amazon, site. Someone decides to buy that or to upgrade that. What is the wiring status? If at all you began with the end in mind, then that is okay, because you know what? That circuit will be able to handle that instant shower head. All right. So if someone decided to upgrade and your initial installation had factored in a cable size such as this one, which is a 4.0 millimeter square, then it will be able to handle that current. But if at all, my friend, you did not, then there is going to be an issue once your customer upgrades. Because how will you take them back to the shop to purchase, these cables, and then to pay for the extra labor work that they will need to pay in order for them to upgrade to this a great instant shower head that uses as well as a heater inside. Smash that if you are already getting some value out of our today's live stream. Glad to have you. Where are you watching from? Let me know, and I will be glad, to know that we are together in this session. So the power supply from the consumer unit will come all the way to this double pole switch here. This double pole switch is referred like so because it switches both the neutral and the phase, that is why it is referred to all. Now, when you look at this switch here, we have the supply that is at the bottom. I normally don't know why they start, but probably it's because of the, don't know whether it is visible, that is supply. And then at the top here, we have that load. You can see, yeah, the load. And of course, at the sides, we have the termination for earthing. Very important for heating circuits. Earthing termination, will be connected to this green wire here. For other circuits, you find that the cable is green with yellow stripes or yellow with green stripes. To me, it's almost like the same thing. Now, this switch, again, as you can see from what we were looking at in our cooker unit, you find that the switching gear, the gun, is heavy. Even the sound produced by the gear or the gun is very, very heavy, meaning switching on and off of those circuits may even lead to sparking. An interruption of a heating circuit can lead to sparking at the point where you are switching it on or off. Is it normal? Of course, yes. If you're switching an instant shower head that is engaged, meaning it is operating, water is running through it, and this switch is either off or on. The moment you switch it either on or off, that is off. When you switch it on, that instant shower head has its heating element engaged. At that point, when you interrupt that circuit, there will be sparking here because you are switching it on load, meaning you are switching it when the load is on. So definitely that will mean that there will be sparking. And I normally say it is normal for many friends of mine who ask me, why is it happening like so? Why are they seeing sparks at, at the point where the cooker? Very yes. So that is about that uh, switching. Now, an important question comes in whereby you will ask me, John, what is the size of that wire? Or basically, what is the size of that cable? What is its size, both the neutral and the phase? Now, let me tell you something. The size of the wire for heaters must be 4.0 millimeter square, the cross-sectional area. Not anything less than that. In fact, you can upgrade and go to 6.0 and so on and so forth, depending on, especially the distance. You know, if you are connecting it over a long distance, you know, you are supposed to factor in the resistance that is normally brought in by distance. You know, if the distance is longer, then it will definitely affect the resistance. If the cable distance is longer, then it will mean definitely that the resistance will be higher. So what you need to do is to ensure that you compensate that. How do you compensate? Simply stepping up the size of the cable. You have probably seen a scenario whereby there is a connection of drop cables where you are connecting from the pole to a property. Now, if at all there is a distance, quite a distance from the point of connection at the utility pole to the property where you have the meter box, if that distance is long, then you will compensate by simply selecting a cable that is of a heavy gauge or a cable size that is, you know, bigger than the normal. So the same applies when we are talking about connections in the electrical installation where we have the wiring, you know, the domestic wiring. Smash the like button if you're already finding some value. I have my good friend here, Kalalo Ismail. Good to see you, my good friend. Says hi. How are you, my teacher? Wow, fantastic. You refer to me as teacher. I'm so glad. I am so fired up and I'm so honored to have you, Kalalo Ismail. And how are you doing today, Kalalo? Wow, so glad that you could join me in our today's live stream. Always an honor. So, where are you streaming from? And thank you so much. It says, I like you, man. Appreciated. Thank you so much. Thank you so much. I am dealing with a very important aspect. And let me tell you why it is important. If, as an electrician, whether you are an upcoming or aspiring to be an electrician, once you grasp this concept, it is going to help you in a very big way. I have an online course and I have touched on this. You can check it out on the show notes where I have its link and you can purchase that course. It is running at a very discounted, a huge discount, which is more than 50%, my good friend. And it is running for a very short period of time because it is reserved for the first come, first served. Whereby, if you are able to understand these concepts, you know, like for instance, the selection of a cable, the selection of the circuit breaker, and you are coming to that in a short while. You will learn a lot, and this will help you understand most of the problems that happen in an electrical installation and come up with a solution. And you know, when you solve a customer's problem, that is how you get paid for it. You don't receive money by chasing it, you receive money by providing value. And I can assure you that my course has a lot of value. The link is on the description. You can grab it, the early bird opportunity. So this cable here must not be less than 4.0 millimeter square when it comes to a heater, be it the microwave. In fact, when we talk about the kitchen socket, like I talked about in a previous video, you might find that a customer has this twin socket that you have connected or is wired in the kitchen. Let me tell you something that happens. They will connect something like a microwave here, and then on this socket they will have an extension cord. That extension cord is probably a 4-way or a 6-way. Then they will have several appliances connected on that extension cord at the same time. Then that will mean that the combined current that is being drawn from this circuit is a lot. And remember, this socket, even though it is a twin socket, it doesn't have a connection for twin or for two cables. It has a connection for only one cable when it comes to the neutral, when it comes to the live or the phase, and you have more provisions for the earth connection. Why do you have those provisions for the earth connection? Is simply to ensure that that connection is tightly done, and it guarantees that the protection when it comes to electric shock is very, very high level. Kalalo is from Saudi Arabia. How is Saudi Arabia? My place here, the great Republic of Kenya, is sunny even up to now. We are just 4 minutes away from 5 p.m. and there is some great sunshine over here. How is Saudi Arabia, Kalalo Ismail? Yeah, so glad to be with you in this live stream of today. And let me tell you something. I always love doing what I am doing now because this is what I have been doing since my childhood. I'm in Saudi Arabia, but I am a Ugandan. Wow. You know, Ugandans are very great people because in my interaction with the Ugandans as well as the Nigerians and even the Ghanaians and also the Gambians, most of them are spread in most parts of our globe, and it is so good. We are very industrious. Also, the Kenyans are in so many parts of the globe, very much spread in Qatar, in USA, in UK. Kenyans are great, and I love that spirit from our African people because we know we have taken the mantle where we are saying that, you know what, we're not slaves, we are not going to, just exist in one place. You're going to explore the world as well as venture into various fields. Could be engineering, could be in tech, could be in transport, and that is so, so great. And I am always honored that you people join me from those countries. It's like, we are moving together with our own, and I really do appreciate. I also said that I have great fans from the Netherlands and from Canada. China has also joined the bandwagon, and I'm so grateful. So thank you so much for being part of this great community. Let us work together. Let us ensure that we are part of this community, and let us continue learning a lot. I'm also learning as I am doing this, and I enjoy it all the way. Yeah. So Kalala is asking about how many types of sockets we have. Yeah, it depends on what you are talking about, especially if you are connecting, the heavy loads. We'll talk about the industrial socket. If you're connecting the domestic appliances, we can have these, you can have the single socket, you can have the twin sockets. So it depends basically on the type of load that you are connecting. A heavy load will be connected to an industrial socket or a socket that will not break down at the point where it is connected to a heavy load? That is a great question from our very good friend Kalalo Ismail. So glad to have you here and also contributing, my good top boss. If you are finding value, smash that like button. And if you'll be watching this video on the record version, feel part of this great community. You are my top boss because you know what? Without you, I cannot be here. Thank you so much for that. So when it comes now to the connection at the consumer unit, that is also another great consideration, because at the consumer unit you must factor in that particular load that you have connected, be it the instant shower head, which is a heater, be it the electric cooker, a heater, you must ensure that from the consumer unit you have that 4.0 millimeter square wire. So when you are talking about a twin socket that is in the kitchen and has multiple connections for the heaters, the microwave, the electric cooker, the electric kettle. Sometimes people even connect the electric cooker there, as well as a bread toaster. All of these are heaters. You must ensure that that cable is nothing less than 4.0 millimeter square in terms of the cross-sectional area, so that you have a good flow of electricity from the source, which is the consumer unit, to that socket. Another important consideration when it comes to heaters is definitely never allow a joint. A joint in that circuit will mean that it is a point for leakages of current. A current leakage will definitely imply that there will be some resistance caused on that point there. So a joint will result to a current leakage because it will spike a resistance there, because I don't know whether there is a way that you can have a perfect joint which will minimize losses, as compared to having a joint that is continuing, or a joint that does not have any break. A cable that does not have any break on its way. So you must ensure that for your cable you don't have any joint. So that is a very important consideration, my top boss, if you are doing an electrical installation. Now another aspect is when it comes to the material that is making that cable. And as I was starting, I talked about the causes that may lead to the resistance of a wire, and I was talking about the material. The material matters a lot. If it is pure copper, then that one will be great for that electrical installation or for that electrical circuit. So like you can see, I don't know whether this one is really visible. Yes, we need to have quality material that will minimize losses due to resistance. The resistance of a wire is increased if the material of that wire is not a good conductor of electricity. So if you have, like, let's say iron will give you a lot of trouble because it will not conduct electricity in a proper way. Now that we are talking about a heater draws a lot of current from the source. When it is drawing current, and then the material that is of that wire or of that cable is not that quality, or is not the one that will minimize losses due to the resistance, then there is a problem there. So you must ensure that the choice of the cable is definitely factoring in all of those scenarios, whereby you will not have an issue when it comes to uh, conductivity of the current or the flow of the current. Now, When it comes to the consumer unit, and shortly I'm going to, zoom into the consumer unit, another problem that will be on that, circuit, the heating circuit, is definitely if there is a loose connection. A loose connection probably at the consumer unit, at the fixtures. Fixtures, I'm talking about the switches, I'm talking about the sockets. Loose connections at this socket will overheat at the fixture itself. At this switch, if you have a loose connection, it will definitely overheat because, like I said, electricity must come in through the face, and for the circuit to be completed, it has to go back to the source, the transformer, through the neutral. Before it gets to the source, which is the transformer, it will have to pass by the safety gadgets in that circuit. Safety gadgets are basically these, the MCBs, as well as these gadgets that are here, the RCCBs. So if at all there is a loose connection on its way, then there will be overheating, because it will mean that there is a compromise on that circuit. And the electricity might detect that probably the size of the wire is too small. That is why there is, the issue of the flow of electricity. And that, in essence, brings about the issue of heating. Heating will now burn this plastic part here. It will cause this switch here to be vulnerable. Remember, you might have the best switch, the best gear, the best gadgets, but if the connection was not done properly, there is going to be an issue. So let me zoom in my camera, and let me know where you are streaming from. And if you are fired up in this session, let me also know, so that we can continue getting some value out of our today's session. There you go. There is my consumer unit. Is it visible to you from where you are watching from, my top boss? There you have it. Yeah. Let me try to have a clear picture there. So that is how my consumer unit is. And I like to talk about the consumer unit, as you have witnessed from my, as I normally say, this is the heart of any electrical installation. If you master this heart, then it will be of benefit to you, as well as your customer, as well as the entire electrical installation. Now, just a brief explanation of how my consumer unit is set up, even though I have an entire video that talks about the consumer unit, and you can check it out. I wired the consumer unit from the start to the end. I will also be linking that video on the show notes, and you can definitely check it out on my channel. And if you have not subscribed to our channel, then you subscribe, so that you'll be able to watch a lot of our videos and learn much more from what we talk about concerning electrical installation. So power will drop at this particular point here, where I have this first gadget, which is the surge protective device, the surge diverter here. And then I have this important gear here, which is definitely our isolator, or our main switch, rated at 100 amperes. And I'll be talking about why it is rated like so in a separate video. And this is our RCCB, the third important device on our panel here, or our electrical board here. From there, we go to now these important devices here, the MCBs, miniature circuit breakers. The way it is arranged is such that it starts with the greater size, or the bigger size going all the way to the smaller size. This is of the current rating to trip whenever there is a short circuit current. For me, because of I'm touching these parts here, but this consumer unit is not live, it is not connected to power. At this particular point, I have a 32 ampere MCB, another 32 ampere MCB, another 32 ampere MCB. I have a 20 ampere MCB and I have a 6 ampere MCB. Why do I have a 32 here? This one can be dedicated to an electric cooker that is in the kitchen. I can have the second 32 ampere MCB dedicated to my instant shower head, and I can have the third 32 ampere MCB dedicated to another instant shower head, assuming it is in the same installation. Or remember, we were talking about a kitchen socket which may be connected to a lot of heating appliances that may draw a lot of current at once, and therefore it is safe for us to have that. So assuming we have a kitchen socket that we anticipate may be connected, a lot of appliances will definitely connect to this MCB here, 32 MCB. 20 ampere MCB can be dedicated to a socket or the ring circuit for sockets there. And we have the last but not the least, the 6 ampere MCB. We can use even the 5. Why? This is a lighting MCB. You know, the light is connected here. Even as you can see, the size of the wire here is a 1.5 millimeter square wire. Again, let me give you a closer look or a closer tour of my wonderfully done consumer unit over here. And I did a very great wiring of it, as well as an explanation which you can easily access it and find a lot of value. We have the earth bars here. I have 2 of them on the sides there, as well as here. I also have 2 neutral bars that are very, very important in this entire setup. Now we are talking about this. The size of the wire that comes from the MCBs should be the same as the size of the wires coming from the neutral bars as well as the earth bars. Why? For every circuit that you connect, let's say a 4.0 millimeter square wire, this is probably that heating circuit we have been talking about. Let's say it is a cooker, an electric cooker circuit, or an instant shower head circuit where you're using, let's say, that 4.0 millimeter square wire. For the face, which is the red for our case here in Kenya, and have the return connection. The same must apply when it comes to the earth connection. See, when you're connecting to the earth bars for that specific circuit, you must have a 4.0 millimeter square. Why? From this MCB here, we have said that power will go all the way to the cooker, electric cooker. Then it has to form a complete circuit and come back. Sorry about that. Time for me to take some water, yeah? So current will have to flow back to the source here, which in our case is this, and it will have to come back to this bar here. So for it to make a complete circuit, you know, it comes out from the MCB through the 4.0 square cable, goes all the way to the connection at the cooker, and then it has to get back to the neutral bars. So when it gets back to the neutral, it means that is a complete circuit. But again, you may ask, John, why would you then have the same size when it comes to the earth connection? Again, when it comes to the earth connection, when we are talking about a heater or a heating appliance, then that means that the issue of earthing should be of greater consideration. Why? Because heaters are normally they normally give out electric shocks if at all that wiring has been compromised, or the appliance itself has an internal fault. If it has an internal fault, there is a high likelihood that it will give out a charge or excessive bad charges to its surface, the metallic surface. Whenever someone gets in contact with that metallic surface, then they will provide a route for the charges to the ground. That scenario may lead to an electric shock. Therefore, the person may receive serious burns on their skin, and to an unfortunate incident, they may even lose their lives. We have this important gadget here that I would like to talk about, which is the RCCB, which will protect or prevent such extreme cases of electric burns on the skin due to an electric shock, because it will simply trip like so. And when it trips, it cuts off the supply of electricity to this bar here, meaning all of these circuit breakers will not receive electricity supply. So you stand a chance to be saved from an electric shock if cut RCCB. When it comes to heating circuit, it is important to note that whatever gadgets you have here matters a lot. If you have a circuit breaker that is, faulty, then there is a problem, because it will not trip in case there is a problem. Direct connections, that one is, I don't know if I should talk about that, because when you connect directly here and you evade this circuit breaker here for one or two reasons best known to yourself, that is a recipe for disaster, as we normally say here at Top Heights Electricals and Electricians. Why? Because now heaters normally, in most cases, have a lot of issues. Either they are drawing a lot of current, either there is a short circuit, either there is an issue of water coming in contact with the face and the neutral, which is also another form of a short circuit in that appliance. If this is not a quality one, or if you have connected an MCB that is not quality in handling that current, then definitely there will be an issue in case it is supposed to trip and it doesn't trip. The connection, like I said, must be done in a way that is only screwed, this screw is screwed on the cable and not on the insulation. If you screw the insulation, then that circuit will struggle to complete itself. The complete circuit will not happen, or there will be a strain in current conductivity, which will indicate high resistance. High resistance will lead to what? Overheating of this cable. So you might have the correct cable size, you might have the correct MCB in terms of the sizing, for instance 32 MCB. You might have a quality material that has made that cable, but my good friend, if at all you make a mistake of screwing on the insulation, or you make a loose connection here, then your quality MCB, your quality cable is useless, because that will mean that that strain there in electricity flow will lead to overheating, because the surface area is not well covered here. That will essentially mean that the size is compromised in terms of what we are talking about. The correct size or a size of a cable will definitely definitely affect, how electricity is conducted. That will mean it will be heavy resistance that will be witnessed there. Thank you so much. My good top boss, Mr. Treasurer, is watching from Kiambu. Wow, what an honor to have you watching me from the same county that I am. My good top boss, Mr. Treasurer, you are welcome to this live stream. How are you doing? And we are talking about this electrical connection, or basically the circuits for heating appliances. And you are right in time, our top boss. This is the best place, of course, that we can talk about electrical connections. So that is about the connection at the consumer unit, and we have said that you must ensure that this connection here is tightly done. Now, another consideration is when it comes to the main switches, and I will also be touching on the main switch that is located in the meter box in a short while before we conclude our live session today. This main switch here is supposed to cut the supply of electricity in case there is an overcurrent. Number two main purpose of our main switch, main, is that it is a point of isolation in case there is need to. So in case you want to cut off electricity supply in that entire electrical installation, this main switch will definitely do the good job. Now, why am I talking about the main switch, or the DPMCB, the double pole miniature circuit breaker? And yet today's topic is about the heating circuits. If at all the connection on this main switch has been done in a manner that it is not tight, then the circuit that is a heater or has been fed to a heating appliance will be compromised. Why? Because this heater, again, like we said, is drawing a lot of current. This current is drawn from the main switch here, or probably from this consumer unit. So yes, you might be having a good circuit breaker, the MCB, the miniature circuit breaker here. We have been talking about a 32 ampere MCB. You have the correct wire size. Okay, the cable is of the correct wire size, meaning 4.0 millimeters square or more. I've done a good connection on the MCB, but if there is a loose connection on the main switch, there is a problem. Why? Because the main switch provides an output for all those MCBs, meaning it provides an output for all the circuits in that installation. Either it is a house, either it is a business premise, wherever. But current, first of all, flows into the main switch before it is distributed to the MCBs, before it is distributed further to the respective circuits. So this DPMCB, the main switch here, or the isolator, plays a key role when you are talking about a heating circuit. If the connection done here is poorly done, there is a problem, meaning there is a loose connection. Then you will find that there will be heating at the point of connection at this MCB here, or at this main switch. Again, another aspect is if that main switch is of a poor quality, it will be affected by the heating circuit. So that heating circuit, where you have that kitchen appliance that is heating, you probably have an undersink heater, which is being used whenever utensils are being washed. Then it will affect these MCB here. If at all the connection done here is loosely done, if at all this MCB is of a poor quality, and if at all it is of a low rate, or let's say the size of this MCB is very, very low or small. I don't know about that. Smash the like button if you are getting value out of our today's topic. We are talking about heating circuits and the selection or the choice of the wire. If you do not consider the wire for that circuit, it will have an issue on your electrical installation, bring about electrical hazards such as electrical fires. And we are going to dive deep into that in a short while as I'll be covering on the meter box as our final segment for today. Good to see you, Owusu Ernest. You say, I'm Ernest from Ghana. I told you we are global, and I have a lot of fans from Ghana. I'm Ernest from Ghana and a first student at an electrical school in domestic. Wow, congratulations, my top boss, for the choice of your career. I have no electrical, so want to take advantage of this program. Absolutely, you are welcome. You are in the right channel, Owusu Ernest, and I'm so proud of you that you took this path. And I am so honored to, be the one to be helping you here when it comes to this important aspect of electrical engineering. So, how are studies coming along in your school in Ghana, my good friend? Practical sessions are the ones that I'm normally interested in the most. In your school, are you having a lot of practical sessions? Are you learning a lot? Do you have such a board? I have a great board here. I can have sessions, when I want to talk about the meter box or the meter board, phase balancing, load balancing. I can talk about the consumer unit, which is an entire, topic on itself. I can talk about solar. As you can see, I have my great panel here that is indoors in my workshop, still charging. I have that charge controller there, and it is still charging despite the fact that it is indoors, my friend. What a great technology that you are having now. And I can also have, actually, in the upcoming video, I'll be getting rid of these electrical installation that I've really covered, and much of it I've also covered in our course that we have put together. And like I said, the link is on the description. The domestic single phase electrical installation, you will learn a lot. You will equip yourself with a lot of knowledge when it comes to that installation. And I've also shared tips on what you can do to ensure that once you have the skills that are in the video, in the entire course, you can also be generating income for yourself as well as for your loved one or for your loved ones by simply having this course and evading a lot of hassles that most of us have gone through. You'll be able to learn so much that some of us we spent over a decade and you will spend in a very short while. So if you want to grab that course, you will learn a lot when it comes to that. So glad to have most of you watching here. Thank you so much for joining me in. As I conclude, at this meter box, the meter box supplies our consumer unit with electricity. All right. So there are mains supply that come from the meter box all the way to the consumer unit. Why am I saying so? Because the size of the wire that is linking the two matters a lot. We normally say it should not be less than 10 millimeter square. This is in terms of the cross-sectional area. But you might be asking me, John, if at all the circuit has factored in the cable size here, we have 4.0. Why can't I use a 6? Now we are assuming a scenario whereby all of these apply all of these circuits here have been connected whereby you have probably two instant shower heads in that house. You probably have an electric cooker that is in use. As an electrician, you must assume the worst case scenario whereby all of these circuits have been connected. So the question there will be, will the mains cable that is connecting the meter box and the consumer unit be able to handle that load at the worst case scenario? Will it? That is one thing that you must factor in. When it comes to the meter box, we also have the main switch here. And the main switch, you must also consider the connection, whereby you must have tight connections. I am always shocked by people who do connections at the meter box using a tester or a lighter tool. That is not acceptable in top heights electricals and electricians. Whenever we are in the field there, anyone knows very well that connections here are done by use of the correct tool, whereby you must use a screwdriver that will be able to tighten that connection. Mr. Treasurer says, I requested if you could cover on material estimation, sir. Absolutely. I'll be dealing with that. I still have your request in one of my to-do list, and I will definitely be covering it. My top boss, Mr. Treasurer. Why do you call yourself Mr. Treasurer? You know, I might hire you so that you may be keeping our, our financial records at top heights. Now, at this particular point here, where we have the connection from the pole, this is a cutout. We have the connection from the pole all the way to the cutout, and therefore, and also we have the output connection, where we have the output phase, the output neutral, as well as the loop for the earth connection. That connection must be tight. If all we have heating circuits, in that electrical installation, the connection there matters, the type of material matters, the size of the cable matters, because if the heaters are on and running and then you have a loose connection at this particular point, even though you have done everything perfect internally, meaning from the consumer unit all the way to the specific appliance that we are talking about, that is the heater, if you compromise at the meter box level, then all the work that you did is in vain, because that circuit will definitely strain whatever connection is here. It will either cause heating at this particular point, arcing, as well as burning of the insulation of these cables. So when we are talking about a connection, for the heating circuits, we must ensure that from the start to the end, from the start whereby we have the connection at the meter box, all the way to the end where we have these heating appliances terminated, the cable size matters, the connection matters, the gadgets that you connect there matter a lot. They must be of quality material or quality make. They must be connected in a manner that they are tightly done, so that you have a perfect path for the flow of current. Remember, the flow of current, if at all it is compromised, then it will have an issue. Oh, Mr. Treasure says it is treasure, not treasurer. Oh, wow. That makes your name great, Treasure. You know, Mm. That makes your name even more interesting and great. Here, I normally call my good friends such as you as top boss. So that one definitely takes you at the top, making you reserve yourself a great seat there at the top as one of my top bosses. Thank you so much for your time. Thank you so much for joining me in for this live stream session. And if you will be watching this video on a record mode, smash the like button. I hope you found some value out of our session. I am so glad that you always stop by to watch my videos. And if you have not subscribed, subscribe to my channel for more of these videos. And any request that you have, I'm at your service, my top boss. Thank you so much. That was my time. My name is John, and this is Top Heights Electricals and Electricians. See you in the next one. Goodbye.